Okay, screen to share हो रही. Let me share again. Okay. Now is it shared? Now do you see my screen, please? Yeah. Okay. Okay.
Yes, sir.
Here we go. Actually, I was talking about that. Yes, when we talk about the thermal physics, in thermal physics we have three main areas to discuss, and there would be two questions. One is the specific heat capacity and thermal properties of the material. Right. This is very simple topic. Topic number one. And the second topic is the ideal gases, and the third topic is thermometry. Okay, thermometry. So, beta ji, when we talk about these three topics, as I told you, that there will be two questions from this area, from this topic. So please be aware of these all. It is important to work on this topic. The areas which will be asked to you from this, you know, from this topic, they are sort of, they are sort of areas which are derivations, logical reasoning, and qualitative and quantitative analysis, and so on, right? So here, this is basically an introductory slide for the thermal physics. So in thermal physics, as I told you, one topic is thermal properties, and this topic consists of specific heat capacity and specific latent heats, etc., etc. Specific heat capacity and specific latent heat. Okay, and the second area, which is basically thermometry, that is very easy approach and very small topic. Very few questions are asked from this one. That is related to the temperatures and thermometers, to somehow temperatures and thermometers, right? The temperature scales, and we will talk about thermometers. And better, the third and the fourth most important is the ideal gases, right? Ideal gases, that is also named as thermodynamics. Okay, thermodynamics. So in this topic, what we will discuss about, we will talk about kinetic molecular theory of the gases. Then we will be talking about the gas laws, okay, universal gas laws. And then we will be talking about laws of thermodynamics, okay, laws of thermodynamics, etc., etc. So this is basically the full description of this topic. And the type of the questions which are asked to you, they are assessment types. In this topic, we will be asked from, or we will be asked about some definitions. This is basically assessment objective one, right? Some sort of descriptions about some phenomena, which is basically your called qualitative analysis, right? Then we will be having some derivations of some equations to show that. Then we will have some calculations based on different areas, right? This is basically your quantitative analysis. These are the qualitative analysis, these are quantitative analysis. The graph questions are there, but not too much. So graphs are also included in. So this is entire domain of your topic, which will be asked to you in from this area. Okay, Jay. Any confusion or any question till this point? So here I have started from the thermal properties of the metal. That why I have selected this topic, because I believe that this topic is the repetition of your prior knowledge, your O levels knowledge. That is why I have started the discussion from this one. So thermal properties are, there are two thermal properties, when we consider when we consider uh, just the thermal properties of the matter, we have a simple concept, some basics about your thermal, right? What is this thermal property? Yes, who will tell me? What are these thermal properties? Can anybody tell me? Yes, Huda, can you tell me, please? Oh, sorry, you don't have mic working. Okay, anyhow, yes, anyone else? Hanzala, can you please tell me? What are the thermal properties? Are you people there in the class? हाँ, थर्मल प्रॉपर्टीज के बारे में बताओ मुझे. Okay, the properties which are based on, yes, anyone else? Which are based on, or which are based at what? The temperature and heat. Okay, temperature and heat. Got this point? Okay, so first of all, I will ask you a question, simple question. What is temperature according to your previous knowledge? Yes, who will tell me? What is temperature according to your previous knowledge, please? An object is very good. So we were considering it as the degree of hotness or coldness. Is it? Is it now? Okay. Okay. So basically here we will consider a little bit different, that there was a definition of temperature, that this is the average kinetic energy. What was the temperature? There was the average kinetic energy of the molecules, energy of the molecules of a substance, right? That was basically your temperature, right? So this definition was also available in your O levels. So that is why I have just mentioned this, that the temperature is actually average kinetic energy of the molecules of the substance, whatever you have. Now, the temperature is not actually the energy. So that is why the next question is, what is then energy? Or thermal energy, or heat energy, you can say. Yes, or heat. This is very commonly used, this word heat. What is this heat? Yes, yes. Come on, come on. The topic is getting slowed down. I had the task to complete. So yes, what is the thermal energy, or what is heat according to your opinion? What do you think about heat? Hanzala? So thermal energy is basically the amount of energy, the amount of energy or you can say the internal energy of a system. Internal energy of system. Yeah, yeah, welcome. So we
Thank
are
you, sir.
just at
Thank
a
you,
new
sir.
topic, that is thermal physics. And in thermal physics, I just stated few points here. The thermal physics is basically a specific heat capacity and latent heat that will be discussed. And in thermometry, we will discuss about the temperature and thermometers. And in ideal gases or thermodynamics, we will talk about kinetic molecular model, then gas laws and law of thermodynamics. So these are the points which we will discuss during this all. And the assessment objectives are your definition and your qualitative analysis. Descriptive questions will be there, writing stuff. And then derivation and calculations are there, which means that you have to to apply some quantitative analysis, and some graphs will also be asked to you. Overall, there will be two questions from this, right? And you are asked to solve these two questions in detail. So that is why I was having a little bit background knowledge from your IGCSE. So yeah, yeah, I was talking about this is thermal. Yani, this was basically your thermal physics. So in thermal physics, if I say, okay, yeah, do you hear me?
Yes, sir.
Yes, sir. Okay, 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 okay. That is fine. So I was just worried that maybe you are not going to hear me out. Okay. So yes, I was talking about this point that yeah, here from your previous IGCSE level, the properties of which are thermal properties are those properties which are based on the temperature or some heat, definitely temperature. So what else temperature? The students told me that temperature is actually the degree of hotness or coldness. Yes, that is. But here in your previous level, you have also recalled one thing, that the average kinetic energy of the molecules is actually the temperature, isn't it? The average kinetic energy of the molecules of a substance is actually the temperature. You got the point? So that means I will discuss about this, that what, I mean, what are the kinetic energy and why the molecules have that kinetic energy, and which molecules or which substances have more kinetic energy and which substances have less kinetic energy, etc. etc. This everything is under discussion of this thermal physics topic. So that is what I was talking about. So you join me at this point. So thermal energy, I was talking about thermal energy or heat. So heat is basically that amount of energy, that internal energy of the system, which can flow from one point to another point, or which can flow from one body to another. Okay, is it? Are you agreed? One body to other. So beta, when you have this situation, to the flow of heat, what do we need? We need a thermal contact. What do we need? A thermal contact. So when there will be a thermal contact, what does it mean? That the heat is being transferred from one body to another. For example, if you people are um, availing a heater, then that heater, although you are not physically in contact with that, but you are availing or you are getting the thermal energy from that heater, and that thermal energy is being transferred from hot body to the cold. This is a hot body, let's say, and when this body is a hot body, then this will transfer the temperature, this will transfer the energy from uh, this to a cold body by mean of a thermal contact. And that thermal contact is basically, it is not a physical contact, or it does not need to have a physical contact. This is a cold body, so there must be a difference of temperature between these two bodies. So that is why the heat will be transferred from one point to another point. You got my point? Is this clear to everyone? So, you know what happens when the energy is transferred from hot body to cold body, the temperature of this hot body decreases, its temperature decreases, its temperature increases. And finally, there is a point, there is a stage which is called your thermal equilibrium. What do we call it? That is your thermal equilibrium. But a thermal equilibrium is that stage where all the substances, yani both the substances which are in thermal equilibrium or all the substances in thermal equilibrium, they all have same temperature. They all have same temperature. Is this clear to everyone? Are you getting my point? So that point or that stage is called your thermal equilibrium. Yani beyond thermal equilibrium, no energy transfer takes place. Beyond thermal equilibrium, no energy transfer takes place. You got it? Beyond or at thermal equilibrium. So this is what I need that background for you. And now I'm just placing another page for you. On that slide, I will try to give you a concept of effects of heat when it enters in the body. You know, all the substances or all the matters, matter is made up of tiny particles. Do you believe this thing? Is it? What is the matter? Matter composes of tiny particles. Is it? Are you agreed? There are particles
Yes, sir.
over here. So these particles can be in the form of solids. These particles can be there in the liquids. These particles can be there in the gases. So basically, all these molecules which are composed here in different formats, I will just draw a small box. Let's say this is just a solid container, right? In that solid container, let's say that is of copper or whatever, there are several atoms which are solid atoms. They are closely packed. So when they are closely packed, what will they do? They will vibrate, right? You got my point. So there will be a regular structure of these atoms, and that is why we say that these are the tightly packed structures. So this is how they only vibrate, right? They don't have the space to move. So this is solid. So in solids, they only vibrate, vibration only, right? And in other words, in liquids, the molecules are grouped, right? In liquids, what happens? The molecules are grouped. For example, they are here, they have a little bit space, so they can move. So they have the vibration as well as translation. Vibration plus translation. Third, they are the gases. But gases are independent of the space wherever you will occupy them, or wherever they will be, whatever the container they will be placed in, they will occupy that space. That is why you can simply say that the gas molecules are far apart from each other, so they have only translatory motion. So that is why if I say that there are two type of energies actually which are possessed by the bodies whenever we consider these bodies, and these type of energies are: one is the kinetic energy of molecules, okay, and second one is the potential energy of the molecules, right? So that is potential energy of molecules. You got this point? Energy of molecules. So these two energies have different traits, right? Those different traits means that if I say that the kinetic energy is possessed by the bodies which have translatory motion, right? I think you know this very well. Is that not? Is it? So here we go. I have to place it right here actually. Okay. Now, kinetic energy is due to what? Kinetic energy is due to motion of the particles. So only due to motion, translatory motion, right? And this is basically based on intermolecular spacing. Okay, or you can say forces. So that is why this is based on vibration. So that is why when I talk about the solids, because solids have almost zero kinetic energy, right? But their potential energy is the total energy. Their total energy is basically equals to their potential energy, molecular potential energy. This is the total energy of them. But in solids, they have some, sorry, in liquids, they have some kinetic energy, they have some potential energy. So they have partial energies here, right? Okay, let me write that. It is if they have molecular potential energy. What about the gases? The gases have only kinetic energy. The potential energy is zero because there is no vibration at all. So that is why if I say that what is the total energy in solids and liquids, so the total energy in the solids and the liquids is equal to the potential energy, molecular potential energy. Here they have molecular kinetic energy plus molecular potential energy, and here they have only kinetic energy. So these three states must be very clear to you. And now, if I define heat, beta heat is actually sum of heat or internal energy, right? I'm talking about heat or internal energy. So actually, this heat or internal energy is sum of molecular's kinetic energy and potential energy due to random distribution of motion. This is very important. Random, I mean, you cannot define which particle has kinetic, which particle has potential. So random distribution of motion. Okay, is this clear to everyone? So remember this thing. This is actually very important information. I will write it again, hopefully. Internal energy, that heat is the internal energy of the system. But I believe that this must be clear to you before I switch to the specific heat capacity and all that stuff. Now, my next brainstorming with you is, if you are going to transfer the heat to a body, right? Transfer of thermal energy or heat, you can say, right? Thermal energy, that becomes the internal energy of the system. When you transfer the thermal energy to a system, that becomes internal energy. So here my discussion should be, or I must discuss with you, what is the system. So who will tell me about a system? Who is taking chemistry? Anyone? System is basically all of your setup which is under observation, all of under observation setup. For example, the gas, the solid, the liquid. Okay, under observation matter are set up. Whatever you have under observation, that is your system. And what about the surrounding? Everything other than the system is your surrounding. Everything other than system. Yani, if I'm just heating up a copper wire, although this copper wire is basically, I'm just holding that copper wire from here, and there is a fireplace here. So, beta, what is system and what is surrounding here? This wire is my system, right? And rest everything is surrounding. You got my point? I believe that it will be very clear to you. If I'm heating a glass container, okay, or a flask of which contains water, right? Then this is my system. I have water in it. This is my system. And if I have heat, for example, if I have placed that in a hot water, let's say this is the hot water and the inner one is cold water. So this is surrounding, right? And this is your system. So this is very important terms. These are, we must know about these all terms before uh, diving deep into our thermal physics. So whenever you are going to provide the heat or transfer the heat from surrounding to system, it becomes its internal energy, right? So when the heat is, this is very important sentence for you, heat transferred to a system, to a system becomes its internal energy. Okay, so when it becomes its internal energy, so at that time you can simply say that yes, this internal energy will disturb, or it will affect two things. What? The kinetic energy of the molecules, yani molecular's kinetic energy. And what about the second? Yes, the molecular's potential energy. So, beta, from here, my topic is divided into two parts. When I'm talking about the change in molecular's kinetic energy, I'm talking about change in temperature, and I will deal all this topic in the topic of specific heat capacity. Now you got this point? Why I just dragged that all till this point. So this is actually the point where I will bring you people. And when I'm talking about molecular's potential energy, so beta, it means I'm talking about the change in state. Got that point? State change. I will discuss that state change in later on, but because right now I'm not having that state change topic in discussion. So state change. So beta, state change takes place where? State change takes place in the topic of latent heat. And as you know, there are two types of state changes. One is basically liquid to solid, solid to liquid, or vice versa. Is it? Do you agree? Solid to liquid or liquid to solid, that is your specific latent heat of fusion. So I will talk about this point here. This is basically your fusion. So I will talk about specific latent heat of fusion. And there is another state that is from liquid to gas or vice versa. This is how, this is basically what type of state change here we will call it about vaporization. Okay, so is this clear to everyone? Yani, now the structure of your topic is clear. Okay, so that is why I have started my topic from specific heat capacity. Before that, this entire knowledge must be there with the student, that how I just switched directly here. Okay, so inshallah, we will discuss this topic by tomorrow, this specific heat capacity and all other stuff. So, is there any question you want to ask me till this point? So, I'm here to answer your question. Is there anyone with any question? No
No, sir.
question? Okay. So, yeah, I have a request to you and Huda as well, that if you have